So refresh my memory again. When we talked about similar polygons, what did we say constitutes similar polygons? What do they have to have? Corresponding angles congruent. Corresponding sides proportional, which means the ratio of their sides are the same, right? All right. So we're going to specifically talk just about triangles today. And we're going to talk about, instead of having to show all the angles congruent and all the sides proportional, there's some shortcuts that we're going to do that apply just to triangles. So if I look at these two triangles, are they similar? We can see that the corresponding angles are congruent, right? We got 40 and 60, so then both of these need to be 80, right? And then if we compare the corresponding sides, we have 32 is to 40, as 24 is to 30, as 36 is to 45. These are all easily reduced. What would this reduce to? 32 over 40. 4/5, right? Okay, what goes into both of these? 6, so that would be 4/5. This would be 9 goes into both of those, so that would be 4/5. So it all reduced to be the same, right? If we divided it out, instead of producing the fraction, what's the decimal equivalent of that then? 0.8, right? Okay, all right? So whichever way you do it, it's fine. Okay, you can reduce the fraction, you can divide it out. If there's just two of them, you can cross multiply. But yes, these are similar. Okay, all the sides are proportional and all the corresponding angles are congruent. Now, would any triangle with 40 degrees and 60 degrees be similar to triangle ABC? And the answer is yes, it would be. Okay, and that leads us to our first theorem. It's called the angle-angle similarity. And it states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And this is what we use to state that. Listen, angle-angle similarity is what it's called. And that's the abbreviation that we use. So if I have two angles in one triangle, congruent to two angles in another triangle, I can say that the triangles are similar. Not congruent, but similar. Okay? And the corresponding sides would follow suit. So let's look at a couple of these examples. Determine whether the triangles are similar. If so, write a similarity statement. Explain your reasoning. Okay, so in this triangle, I've got a 57-degree angle and a 48-degree angle. I need to figure out what this other one is. What do we know about all the angles of a triangle? Add up to equal 180. So this angle up here, angle J, ends up being 75 degrees. Okay? So with that said, if this is 75 and angle L is 57, is it similar to this other triangle? Yes. By what? The angle-angle similarity. Okay, now it does say write a similarity statement. Okay, remember a similarity statement is where you say, okay, triangle JKL is similar to, and when you write the other one, you got to put the corresponding angles in the right spot. So J goes with Q, K goes with T, and then N, right? So that's my similarity statement. All right, here's another one. This time, I'm not really getting any angles, but I see that I have a pair of parallel sides, or lines, that are cut by two different transversals. What can I get from here? I have two what? Okay, so we've got a pair of alternate interior angles here. We've got vertical angles, or we could use the other pair of alternate interior, right? I wouldn't need both of them. I could use both of them. So are these two triangles similar? Yes, by angle-angle similarity. Okay, so my similarity statement, let's say I did what? XSR would be similar to TSW. Okay, so those triangles are similar by angle-angle. Okay, all right. There's two other ways that we can prove triangles similar. And the first one, or the second one, I guess, is by showing that all the sides are proportional. You don't have to know anything about the angles. If we can show all three pairs of sides proportional, then that is sufficient. Okay? So, you would set up, all three of these corresponding sides would have to reduce to the same fraction or decimal. And then the third way is by the side angle side similarity. And sometimes we show, let's go back up here to showing the sides are similar. These are written as a fraction, but we see that AB is to DE. That means it's multiplied by some factor. And BC is to EF. That's multiplied by the same factor. And then AC is to DF. Again, multiplied by the same factor. Sometimes they show it like that. But if you were stating it, you would do the three fractions. All right, and then the third way is the SAS similarity. And it says at an angle of one triangle is congruent to an angle of another, and a second triangle, and the sides that include the two angles are proportional, and the triangles are similar. So we have a pair of angles that are congruent, and we know that this AB is to DE as BC is to EF. Okay, so you've got a pair of proportional sides that sandwich in that congruent angle. Okay, that congruent angle has to be in between those proportional sides. And so that's the side-angle-side similarity. So those are our three ways that we can prove triangles similar. So, determine whether the triangles are similar, explain your reasoning. Alright, so looking at this, what might we want to do here? What do you notice? Okay, we've got a pair of congruent vertical angles, okay. Okay, so how do you want to set it up? So you want to do 8 is to 12.5. Okay, but we've got to make sure it works. So 8 is to 12.5 as 5 is to 20. I don't think that's going to work. I don't know what doesn't. That's not going to work. Because if I did that, and I'm glad you made this mistake, this right here is going to be 160. Well, no, because this is important. If we take 12.5 times 5, we get 62.5, right? So what might that tell me? If that didn't work, is there another possibility? Right. It would be 8 over 20 and then 5 over 12.5. Okay, let's try that. So 8 over 20 and 5 is to 12.5. So this right here is 100, and if I cross multiply it, I get 100. So are they similar? Yes. It's important to marry up the right sides, and sometimes we don't, so sometimes you got to check more than one thing, okay? All right. So yes, these are proportional. By what? The side-angle side similarity. Okay. And so then if I did my statement, this one, it doesn't ask, let's do it, make sure we know what we're doing here. So if we did what? PQR, that would be similar to what? STR. Okay. Now, I was given information about all three sides. You think I could have used SSS? Yeah, I would have had to have checked all three sides if I did that. Okay, but the vertical angles made it easier to do the SAS. Okay, here's another one. What do you think here? You think these are going to be similar? You don't think so? Are there even two triangles there? What about this triangle here and this triangle here? Oh, that sheds a little light on the subject, doesn't it? Okay, do they share an angle? A, right? Okay, so they share the angle A, so I potentially can have side angle side, right? So we've got a small blue triangle and a large red triangle. So we've got to compare those sides. So what would 8 correspond with? 8 to 12. Okay, and then this side here is 15. So we would say, okay, 8 is to 12 as 10 is to 15. And they both reduce to be what? 4. 2/3. What size is it? You guys take an F in reducing fractions. You're too dependent on those calculators. What goes into both of these? A 4. right? Both of these of 5. Okay? And what is the decimal equivalent of 2/3? 0.6 repeating. Okay, so are these similar? Yes, by the side angle side similarity. I don't think it's asking us. In your homework, they'll probably ask you for a similarity statement. Yes? No, I'm not going to do anything. We probably won't do much more. Maybe a little bit in the chapter 9 or something. Okay, but it's a different kind of proof in chapter 9. And honestly, we're doing proofs right now. We are. They're just not 2-column proofs. Because we're validating the fact that 2 triangles are congruent given the rules, yes? We're not having to write it in words now. Okay, here's another one. Okay, are triangle ABC and triangle DEF similar? Determine whether the ratios of the corresponding side lengths are equal. Okay, so what are we looking at here? Which one of the ways are we going to test? Probably the side. So I would marry 3 up with what? 4.5. So 3 goes to 4.5, and 4 goes to 6, and 5 goes to 4.5. Oh, thank you. 5 to 7. Okay, so this one might be one where I divided it out. I can tell that it is, but you may not be able to recognize it. So 3 divided by 4.5 is 0.6 repeating. This is 2/3, so it's going to be 0.6 repeating. And if I take 5 divided by 7.5, again, I get 0.6 repeating. So, are these similar?
Yeah.
Yes. Yes, by side, similarity. Okay. Now, this one's a little tricky. It says, are triangle PQS and RQP similar? Okay? So we've got PQS, which is the large red triangle. Okay? And then we have similar to RQP. RQP. Now, notice how they have these listed. Okay? I'm going to redraw them. And I want to orient them to be the same. Okay, what does that mean? Well, here is here's the big one. It's just like it is in the picture. S, P, and Q. Okay, so PQ, PQS. Then this one would be R, Q, P. What they did is they took this blue one and did what? What did they do here? They reflected it about this Q, right? They took it and reflected here. This stayed here, but they took this and brought it down here like that, right? Okay, so this long side here corresponds with this longer side down here. Does that make sense? Sometimes when we work with similar triangles, they don't orient it. They rotate them, they flip them, they do whatever. I have a hard time seeing that, so I have to use a redraw. Okay, so I just recommend that to you. Okay, so let's label everything. PQ is 18. QS is 27. And RQ is 12. And again, PQ is 18, right? Now, they both share what? Q, right? So we know that those are equal. So I need to see if these sides are proportional. So I have 18 is to 12. The side is to this side. As 27 is to 18. Okay, and I can reduce that, or what goes into both of these? Okay, what else? 6, 6, 12, 18, and 6, 12. So that's 3 halves, right? Okay, what goes into both of those? 9, 18, 27, and 9, 18. So are these triangles similar? Yes. Yes. By what? Say it. Okay. All right. Avery puts up a radio antenna tower in his yard. Ella tells him that their city has a law limiting towers to 50 feet in height. How can Avery use the length of the shadow and the shadow of the tower to show that his tower is within limits, in the limit without directly measuring it. Okay, so the key word here is shadows. And see, look where the sun is. Okay, the sun is shining, and if you take the same time during the day, it exhibits these rays. And the rays create the shadows on the ground, right? Now, if you remember back from earlier on, let's say this is the ground, here's a ray, and here's a ray. My drawing skills are lacking. Here, and then, okay, what's going to be true about the sun rays? At the same time during the day, what are they going to be? Parallel. Okay, they're going to be parallel, and this is the ground, right? So if that's the case, then what's true about these two angles right here? They're congruent, right? Because what kind of angles are those? Corresponding. Okay, so that's what's happening here. Okay, you've got this dude, what's his name? Avery. Avery's here, and you've got the tower here. You've got the sun, these are the dotted lines, the rays. And then you have their shadows. 5 for the Avery, and 40 for the tower. We know that these two angles right here are equal, and then the tower and Avery are perpendicular to the ground. So these two triangles are similar by what? Angle, angle. Okay? So I want to know if this right here is too tall. So what can I do? Okay, so you're doing 5 over 6 equals 40 over 8, over x. Would that work? Yeah. Could you have done 5 is to 40 and 6 is to x? That would work too either way, okay? All right. I'm going to write that down. 5 is to 40 as 6 is to x. So either one of those proportions would have worked. All right, so we cross multiply, and we get 5x equals 240. We divide both sides by 5, and you get x is 48. So is Avery in good shape? Yes, Avery is in good shape. Okay? Because his tower is, and he didn't have to climb up there and measure it, did he? He just used the sun. Okay, now, if the tower were 50 feet tall, how long would the shadow of the tower be? So we're changing the problem up just a little bit, and we're saying, okay, now this is 50. How long would the shadow be? So what would you do in a case like that? We could, I don't know if we would necessarily need it, because we still have set up the proportion. You could use the Pythagorean theorem, but that would just tell you how long the sun ray is from the top. So if we did 6 is to 50, we would do what? 5 over x, so we get 6x equals 250, and 250 divided by 6, I keep getting clearer for divide. 250 divided by 6, 41.7 approximately. So that would be what is the sun ray. What? 41.7? Did I say 46? No, I don't think I did. All right, I might have. Who knows? Okay, here's one more. Find BE and AD. So I want BE, which is my x, and AD, which is my y. Okay, first of all, do I have two triangles? Yes, I do. I have a small one and I have a larger one. Okay, they both share angle A. So we've got this little blue guy. Okay, and then we've got the big green guy. Okay. Are these triangles similar? Well, they share this angle, right? What is this parallel line cut by a transversal tell me? Corresponding angles, right? So are they similar? Yes, by angle. Okay, so I want to find BE. Solomon, how am I going to find BE? BE is my x. Now the triangles are similar, so what does that tell me about the sides? Okay, but what does that mean? There are corresponding sides, but the corresponding sides are what? Ethan. Proportional, right? So to get x, I'm going to set up a proportion. Okay, so, Ian, is your hand up? So what do you want to do? Okay, so we're doing green to blue, right? Okay, so he said do 5 over 3, and then 3.5 is to x. So we cross multiply, and we get 5x equals 3.5 times 3, which is 10.5, and so x is 2.1, right? Okay, and what am I going to do for y? Could I still use 5 over 3? I still use 5 over 3. I'm doing big to little, right? Green to blue. Okay, what's green? What, is it 3y? 3y is 3 times y. Ah, there we go. So this right here is y plus 3 to y. Okay? Alright, so we cross multiply and we get 5y equals 3y plus 9. So that's 2y equals 9. And so y is 4.5. Alright. So what are the 3 ways that we talked about to prove triangles similar? Angle, angle, side, 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 angle, side. The angles have to be congruent, right? When you compare the sides, they have to be what? Proportional. Okay.